Hi, good evening, everyone. So welcome to this SoPHE technical event. My name is Giovanni Tocco. I am the SoPHE UAE chair, and today we're going to talk about domestic hot water balancing and Legionella control, presented by Caleffi. So general note, CIBSE SoPHE responsibility as a region is to promote the intellectual welfare of its members and improve the understanding of building services engineering within our society by organizing events and other activities related to the built environment. Journal information, so SoPHE journal information. For any information with regards to membership, SoPHE journal, technical information, etc., please visit the CIBSE website. And for any public life engineer on the call, if you guys have any question or queries with regards to SoPHE membership, please contact myself on giovanni.tocco@wsp.com. Please note that any upcoming SoPHE event will be posted on CIBSE UAE LinkedIn page. And I would also encourage all public life engineers on the call to visit the SoPHE LinkedIn page for any updates on public life engineering. So coming back to the main event for today, the presentation will be on domestic hot water balancing and Legionella control. The speaker today is Mr. Alessio Sioni from Caleffi. Session note, please stop your question on the Q&A panel that will be answered by the speaker during the Q&A session. This will be on your screen, top right corner, so you can type your question in, and then we will get that through to you after the presentation. Your camera will be off and your mic will be mute. And on that note, I'll hand over to Alessio. So Alessio, without any further ado, if you want to take over.
Hello, everybody, and welcome to this session. Greetings from Italy. Now, just give me 1 second to share my screen, and then we can start with the presentation. Can you see my screen correctly?
Yeah, all good. You can go on. Yeah.
Okay, so today we will spend almost 1 hour together speaking about domestic hot water system balancing with particular attention to Legionella control. In other words, we have to evaluate what is the importance of a good performing domestic hot water recirculation system. So in order to start, let's remind together what are the targets that in design phase we have to consider and take into account in order to have a good performing efficient domestic hot water recirculation system. First of all, some of them are related to the comfort of the user. I mean, the domestic hot water shall be available to the user in the shortest possible time. There are also some standards for that. The hot water and cold water flow rate shall always be adequate, so I never have to miss availability of water. The temperature of the water shall be adequate to the use and stable despite the system fluctuation in pressure that may occur. Second aspect to consider is the safety of the users, with particular attention to Legionella bacteria that I have to avoid or eliminate. I also have in these regards to avoid water stagnation throughout the system, but at the same time I have to consider the safety of the users from the scalding risk. All of this has to be achieved with the maximum possible efficiency. So we have to optimize the use of the thermal energy, and we have to avoid as much as we can the water waste. So let's try to focus on what are the main control devices throughout the system. We can identify a lot of players in this role. In particular, we have to control the temperature with temperature control devices. We have to control the recirculating flow through some other devices, and we also have to manage correctly the pressure throughout the system with pressure control devices. So we will have a short overview of this family of products, and we will try to focus on their features. So let's start from the temperature mixing valves. Temperature mixing valves are control valves in order to control the temperature downstream to them. So these can be the typical schematic of a medium big system. We can already identify different devices in different positions, so we can identify some mixing valve at the point of distribution, so close to the hot water storage or to the hot water generator, but we also can identify peripheral devices, peripheral mixing valve that we can define mixing valve at the point of use. Despite their operation might look similar, their features are completely different, and also some technical standards that they have to comply with. This is the typical trend of a hot water temperature throughout a medium mix system. So we can easily identify 3 areas: the storage, where the temperature is kept at a very high value. We are speaking about minimum 60 Celsius degrees. This is for the safety. This is for the safety versus Legionella. I think everybody knows already what Legionella is. The Legionella is a bacteria living in the water, naturally present there. At some certain temperatures that we can identify below 20-25 degrees, Legionella is there, but is not active, so it's not dangerous for the human being. Above some certain temperature that we can identify as 50-48 degrees, Legionella starts having issues and dying. So the higher is the temperature and the quicker is the death of this bacteria. So just to give you an example, at 70 Celsius degrees, the death of the bacteria is almost instantaneous. The temperature range in between is an optimum environment for the Legionella spreading, and unfortunately, it is also the optimum interval for domestic water use. So our system has to manage this risk the best possible way and defeat the Legionella, if possible, everywhere through the system. That's why the storage is kept hot. In the distribution phase, for safety reasons and to avoid too high energy waste, the temperature has to decrease, has to be reduced from 60 to approximately 55 or 52 Celsius degrees. That's what we see on the supply line to the distribution system. In medium mix system, there will be a recirculation pump with a recirculating water temperature. Let's suppose it is 50 degrees. It's a typical value. Before of the final use, in order to protect the users, that can be also weak people or very delicate, like children, elder people, or if you imagine people in the hospital, you have to ensure a final temperature reduction up to 38, 40, or 43 Celsius degrees. And this will be obtained with a peripheral mixing valve installed at the point of use. Let's start from the first valve. So the first temperature reduction is done by mixing valve at the point of distribution. Usually these kind of devices have high flow rate capacity. They have to manage the water flow throughout the whole system, so they have to have big kV values. The adjustment temperature range is medium-high. We are speaking about up to 65 Celsius degrees. They are installed close to the generator or to the hot water storage, serving a recirculation loop, and they are connected also to the return pipe. We will see later in detail. Some of them have programmable thermal disinfection features. We are speaking, for instance, about the Caleffi 6000 series Legion Mix. They can be programmed to perform the thermal disinfection throughout the whole recirculating loop. Such type of valves are engineered to operate in stable condition with a fixed mild pressure ratio between hot water and cold water that is maximum 2:1. They always need a minimum flow always running through them in order to be stable and efficient. In detail, what do we mean about thermal disinfection of the system? This is a schematic of normal operation of a digital mixing valve in Legionmix. We see that we already saw that the hot water storage is safe because it is kept at a high temperature, 60-70 Celsius degrees, and so far we are safe. But before we told that for safety reason and for energy use purpose, we have to reduce the temperature. So if you imagine how big can be the recirculating loop of a tower or a hospital or a medium mix, we have liters and liters and kilometers of pipe exposed to Legionella growth and proliferation. So The digital mixing valve Caleffi Legionella is able at a certain time, at a certain temperature of usually in the night, to perform the thermal disinfection of the system. It means that the cold water inlet will be completely shut off, and the water at the same temperature of the storage will flush the whole system for a certain period of time that we will fix. The digital regulator of the valve or the BMS system will be programmed for it, and they will state whether the thermal disinfection will be correctly achieved or not. In case of hot water flushing of the recirculation system, the user, of course, the user has to be aware of it, but in any case, if you remember, we put a further thermostatic mixing valve to protect the final user. So even in case of thermal recirculation, thermal disinfection, my users will be safe anyhow. So let's go in detail and see the features. Caleffi Legiomix has been developed something like 15 years ago, and it has been implemented during the years. So the latest version have very, very high flow rate capacity. We are speaking about up 120 cubic meter per hour. Of course, their temperature adjustment range is medium high because they have to distribute and control the water temperature throughout all the building. They can be programmed for the thermal disinfection, and in order to check the real achievement, they are equipped with double temperature probe. So they have two probes, one for the supply and one to be installed on the return of the recirculation pipe. All the data are updated daily, they are recorded, and once an hour, the temperature are recorded. They are equipped with a digital programmable regulator that in the latest version can be connected to the BMS network, Modbus or BACnet. This kind of solution complies with the guidelines for control of Legionella in water system protocols, also the version by Dubai Municipality. Dubai Municipality protocol forecasts the periodic flushing with water, if I remember correctly, at 70 Celsius degrees, and these valves allows you to achieve this operation. Let's go to the other family of thermostatic mixing valve, the peripheral units to be installed at the point of use. They are always three-way valves, but their features are completely different. The kV value is very low, so they were engineered to manage low flows. I mean, the flow of a washroom, if not the flow of a single faucet or shower. They are certified by third party with the anti-scald feature. So I reported you TMV3 and TMV2, but they can be also ASSC certified for protection from scalding. They are usually equipped with built-in check valves and strainers at the inlet. They are engineered to manage a very high pressure ratio. If you remember before, the maximum pressure ratio was 2:1. Easy, because we were in the thermal room in stable condition. In the distribution, we can have, depending on the demand, very high fluctuation, and these valves are engineered to comply a pressure ratio between hot and cold or reverse up to 6:1. That is a very high value. The adjustment range is lower than before. We are speaking from 30 to 50 Celsius degrees, and they are installed at the end of the distribution line just before the final users. So when designing a project, we decide to input in the system a temperature regulating valve. First of all, we have to ask ourselves, where do we have to install it? At the point of distribution or at the point of use? So this already allows us to identify some certain product range different from the others. The second question that is crucial is how big has my valve to be? So the sizing process is crucial for the thermostatic mixing valve or digital mixing valve because it will ensure and grant the stability and the accuracy of the regulation. So first of all, we have to calculate the design flow rate. The design flow rate depends on the type of user, depends on the number of users, but it also depends on the simultaneous use factor. That is a probability. This probability is related to the nature of the building. a hotel, a hospital, an airport, a school, or a private dwelling, they have different simultaneous use factors. So there are some tables that explain it. Second step is, let's state the pressure drop caused by the valve. Let's remind. Thermostatic mixing valve is a control valve, and control valve has to cause a certain pressure drop in order to influence the behavior of the system. If the pressure drop was too low, it means that my valve is not able to regulate. So the target optimum value of pressure drop caused by a thermostatic or digital mixing valve is half bar, so 5 meters of water gauge. The interval within which it is acceptable start from 3 meter water gauge and finishes to 7 meter water gauge. So if our pressure drop is within this interval, the valve is correctly sized. Let's consider a couple of examples. Let's consider a hotel. Let's consider a hotel where the designer decided to have a thermostatic mixing valve serving the single washroom. So is selecting an installation at the point of use. Installation at the point of use will require some certain features, so anti-scald feature and a mild temperature setting, because it is the last protection before of the user. So, for instance, we identified Caleffi 5213 series. This series is available 1/2 inch, 3/4 and 1 inch. You don't see 1 inch here because it's the news of the year, but we have to select what is the proper size. So let's calculate it. The design flow rate of this washroom, we consider 1 wash basin, so 6 liters per minute as standard can be acceptable. And then what can I have? A shower. So total flow rate is 15 liters per minute. I am serving the single washroom. So my simultaneous use factor in this case can be considered 1, so 100%. So I will take Caleffi 5213 technical data sheet. I will take the hydraulic characteristic chart, and I will enter with my design flow, that is 15 liters per minute. If I identify the M15, so 1/2 inch valve size, my pressure drop is around 0.4 bar, so 4 meter water gauge. That is very, very nice. So the proper size for this application will be 1/2 inch. If the same way we want to consider the installation of a digital mixing valve serving the whole hotel, for instance, we suppose 150 rooms. In this case, we install the device at the point of distribution. So, and it is a hotel, so I need big flow rate capacity, of course. I need a higher temperature setting because I have to do the first temperature reduction. And I need to be able to perform the thermal disinfection, so I move towards Caleffi 6000 series, so the electronic mixing valve. Now, let's calculate the flow. We just told we have 150 rooms. If we forget for a moment to have the kitchens, another service room, and consider just the real hotel rooms, we have 150 basin and 150 showers. So the total sum is 2,250 liters per minute. For this size of a hotel, the simultaneous use factor given me by the table is around 13%. It means that my design flow rate is not 2,250, but 297 liters per minute. The same way we go on Caleffi 6000 series technical data sheet, and we go to the hydraulic characteristic chart. We enter with the design flow we just calculated, so 297, and we notice that for 1.25 inch, the electronic mixing valve, the pressure drop cause is around 0.7 bar, so 7 meter water gauge. That is fine. So the correct size for this application is 1.25 inch. Never mind if the pipe that I calculated is bigger. Now, we saw the features of the devices in detail, but we have to remind that devices are part of a system. So we have also during the design phase to take account of the boundary conditions. So there are other elements, even simpler in the system that may affect the correct operation of the valve. So if the thermostatic mixing valve or the electronic mixing valve is sized correctly, selected correctly, but installed the wrong way, or if in the system there is a lack of some devices, for instance, the check valves, I might have influence to the normal operation. So let's start from the check valve. That is one of the most important accessories around the mixing valve. So don't forget the check valves. In the diagram, the typical diagram of a medium big mixing valve, can be digital or can be thermostatic, we have at least 4 number of check valves. We identify them as check valve number 1, 2, 3, and 4. So let's try to do a scenario. We forgot to install check valve number 1. Check valve number 1 is protecting the inlet of recirculated water in the cold water inlet of the mixing valve. What if I forgot it? If I forgot it, I might have undesired inlet of cold water in the recirculation loop. If the system pressure is very high, it can go backwards, potentially damaging the recirculation pump and for sure reducing the temperature in the recirculation loop. So the users will not have the desired hot water temperature, so they will comply. With the same method, let's try to forget check valve number 2. Check valve number 2 is protecting the water coming from the recirculation loop towards the hot water storage. If we are missing it, we might have undesired backflow of hot water from the storage backwards to the loop. So I might have potential damages to the pump because it is facing backflow. And also the temperature within the recirculation loop will rise. So there will be lack of comfort and potential danger for the final users. So let's finish the scenario. Let's forget check valve number 3. Check valve number 3 is protecting the inlet of cold water in the cold water inlet of the valve. If I forgot it, I might have injection of recirculated water within the cold water line, backwards up to the main distribution line. So I might have also a potential pollution to the municipality network or to the bidding network or to the main line. Check valve number 4. Check valve number 4 protects the cold water inlet in the storage. If I forgot it, I might have backflow of hot water and recirculated water towards the cold water line, so towards the distribution network and towards my valve. So my mixing valve will receive hot water and hot water too. So it will affect the comfort, the temperature, the regulated temperature will fluctuate, and I will have inefficiency and poor comfort. Another tip, consider to ensure, we told before, these kind of valves need a minimum recirculating flow rate, always. So all the technical data sheet of any mixing valve reports the minimum flow rate to ensure the valve in order to have a stable operation. So take also this data into account when you size and when you choose the recirculating pumps. The last tip on this regard is related to a very important connection that it is often forgotten, the connection of the recirculated loop to the cold water inlet of the centralized mixing valve. This connection is crucial in order to grant the valve the minimum water circulation we discussed 1 minute ago. So let's suppose we forgot it. So let's take it out. And let's suppose there is no hot water demand from the users downwards. So my hot water is circulating and circulating. And there is no demand, so there is no way for the new fresh water to enter my loop because nobody is asking for water downwards, so it will not enter. If cold water is not entering the loop, the consequence is that the temperature in my recirculating loop will rise. But if the temperature in my recirculating loop is rising, it means that the mixing valve will start closing the hot water inlet. If cold water inlet is closed and hot water inlet is closed, also mixed outlet will be closed. So I will have complete lack of water circulation. So my users will not have hot water, so poor comfort, and furthermore, my pump, my recirculation pump will push towards a closed system, so it might get damaged. So these were just some design tips for mixing valve installation and design. Now, this is the list we put on the table before. So far we reached some of the targets, but not all of them. Some of them are not related to temperature regulation, but they are related to temperature distribution. So it's another aspect. Recirculating loops. Recirculating loops can be a very big headache if not designed and balanced the proper way. So the sizing of a recirculating loop, it is based on a couple of fundamental parameters that are the linear thermal loss of the system, and it depends on the material pipe, on the insulation of the whole building. From the literature, we know that an average good reference value can be 7 watts per meter of length. And the other parameter that the design is usually required to fix is the delta T between supply and return. There are two ways commonly. The most common is to state between supply and return a delta T of 5 Celsius degrees. This is one of the most popular way of designing. The other one states that between supply and the farthest point of the system, I shall keep 2 Celsius degrees. The final result is almost equivalent. So if I combine these two values, I obtain a unit flow rate per meter of pipe that is 1.2 liters per hour. So for every meter of pipe of my system, I have to supply at least 1.2 liters per hour. So it depends on the length, basically. On the other hand, we stated it before, it was one of our targets. We also have to comply certain standards according to which my domestic hot water shall be available from the moment I open the tap within a certain period of time. This is also related to pipe length. So when we are requested to design, for instance, a 5-star hotel or a hospital where people cannot wait so much time in order to have hot water, I cannot put the recirculation loop connection and the tap too far. That's why the recirculation loop, it is better to be as capillary as possible. Then these were some comments and some tips concerning the sizing and the design of them, just a few. Another big headache is the balancing of them, because so far the system is sized, the system is designed, but I have to grant somehow that the distribution of the domestic hot water temperature throughout my big system is right. So this is a common situation of imbalanced system with a centralized recirculation pump and many risers serving a different washroom. We can always identify 3 areas, the closest to the pump where the temperature is even more than enough. So I can have a risk of scalding and danger. An area where the temperature is not enough, it's not what I designed, because it's a matter of system balancing. So in this orange area, I am not giving enough thermal power, and the result is poor comfort and possible Legionella proliferation. So I have to take this aspect into account in order to grant the safety throughout all the building. The area in between is more or less fine, but its condition of safety depend on the usage rate, on the demand, because if everybody is asking for hot water in another part of the building, this area will get colder too. So Balancing for us means to introduce into the system something in order to grant the correct flow rate distribution. A classic method was the usage of and the application of manual fixed orifice balancing valves, so DRVs. This system works with some benefit, but some limits. For instance, let's suppose I put my double regulating valves throughout the buildings. I was able to calibrate, and it's not easy, every one of them to the correct value. That will be the value of bigger demand, of bigger temperature drop, so the highest flow rate scenario possible. In this situation, I have correct design flow rate to each branch. This system is compatible and generates no problem in terms of thermal disinfection, like acted by Caleffi 6000 Legionella series. Then let's start with the limit. The branches are always supplied with 100% design recirculation flow, even if this thermal power is not necessary, so they cannot grant the optimization of the thermal energy. Second, we mentioned previously, the commissioning process might be tricky and will take a lot of time to the contractor. Sometimes it is neither done. And the change of any single calibration or the replacement of any single valve in this system will affect the setting of the whole system, so the process of commissioning and calibration has to be restarted from the beginning. Now, for these reasons, some other type of solution have been developed throughout the years that are not fixed orifice, but they are thermostatically driven. So it is the case of Caleffi 116 series. We see a draft of a recirculation system imbalanced with a bad temperature distribution, and we insert a thermostatic balancing valve for each riser. The calibration is very easy because I just have to rotate the knob until the temperature I design is reached. And in this case, it was around 50 degrees. How does it work? Internally, there is a thermostatic element sensitive to temperature. And as soon as I come closer to the set point, the valve is able to reduce gradually its hydraulic characteristic and reducing the flow rate through that ring or riser up to the minimum. When I reach the set point, the KV of the valve is minimum, is not zero, because some water has always to be running in order to keep the pipe hot. So let's suppose to install these devices replacing the double regulating valves, and this is the situation. So what is my scenario? I am granting the correct design flow rate to each branch. This system, we will see in 2 minutes, is compatible, can be compatible with thermal disinfection. The recirculation flow is based on the current real thermal needs of the ring of the loop. In other words, the valve is able to modulate, granting me energy saving. The commissioning process is very, very easy. It is enough to rotate the knob up to the desired value. And the valves are also equipped with a pocket where you can install a temperature gauge or temperature probe in order to meter the current temperature throughout all the building and in every single branch. What about the compatibility with thermal disinfection? There are two ways. One way is thermostatic and the other one is electrothermal. It is basically a bypass function. So this is the installation of a thermostatic balancing valve with integrated recirculation disinfection cartridge. So we saw before, when the set point temperature for the primary regulating cartridge is reached, the valve gets to the minimum flow. But as we get 68 or more degrees, the valve starts opening the bypass way. So I will never miss my disinfection flow when it is needed. So when the digital mixing valve is giving me 70, Celsius degrees, for instance, for the thermal disinfection, the valve will have the maximum bypass flow possible, so I will never miss recirculating disinfection flow rate. The most complete configuration of this family of valve is with electrothermal bypass cartridge, and this is shown in this small video. So as soon as disinfection time has come, we will see that the digital mixing valve will provide an electrical signal to the system that can be brought up to the electrothermal controllers in order to mechanically bypass the valve. You will see that also in this case, that we will never miss the disinfection flow rate. For instance, this is a normal regulation, so my primary cartridge is reducing progressively the flow rate, but disinfection time has come, so the digital mixing valve is able to manage the opening or closing or the electrothermal bypass. So my flow rate will start increasing again for the period of time I decided, and the water will be at the right temperature we design in order to carry the thermal disinfection of the system. A special overview on the combination of a digital mixing valve and electrothermally actuated thermostatic balancing valve, because this digital mixing valve can be connected to the BMS, but also the electrothermal bypass element can be connected to the BMS system. And if you remember, we have a pocket. If we replace the temperature gauge with a temperature sensor, we are giving the customer a complete package in order to control and perform the thermal disinfection throughout the building, controllable by remote, from remote with BMS. Also, this system enables the user to perform the thermal disinfection of the branches and or of the riser separately, so step by step. So maybe the program can be, let's flush today riser number 1, tomorrow riser number 2, and the day after tomorrow riser number 3. It can be done with the BMS integration. So I can control the single flow and area. I have live monitoring of the temperature in each single branch. And also I have the live monitoring of the temperature in the thermal room, because if you remember, we have the probes. And I also have a live detection and correction in case of any anomaly in the system. We are missing the last regulating element, that are the pressure controlling valves. Also, the pressure is a hectic parameter to deal with, especially in medium big buildings. So this is the typical situation in a medium big building. So I have an inlet pressure value in the building, and then I have a distribution system. So here I have a multi-story building entering with a 3.5 bar. For gravity and for linear pressure drops, I am reaching the highest dwellings with a non-sufficient pressure value. And this is translated in lack of flow rate and lack of comfort. On the other hand, at the basement, at the lowest floors of the building, I have a pressure value that is too high. So I have an extra amount of flow rate, so I have a lack of comfort and potentially dangerous condition. In between, I am in a comfort situation, but it will be fluctuating based on the demand of the other stories of the building. Moreover, this is from literature, the result of a simulation of a time lapse of 5 minutes. And we have an optimal set pressure value that is 1.5 bar, but the pressure throughout the system is not correctly balanced. So I am entering with 5 bar from the main connection, and I am granting 1.5 bar to the highest floor. But the floors that are below are subjected to a too high pressure value. And in a time lapse of 5 minutes, This percentage shows what is the waste of water caused by the extra pressure. So the average of the building is plus 29%. And the poor family living at the ground floor will have more than 50% of water waste. So this will be translated in a very, very higher bill. So pressure is absolutely a parameter to regulate. So how can we do it? Okay, let's suppose the situation of before. I'm entering the floor with 3.5 bar, but the highest stories are not correctly supplied. I am missing water pressure. So the most common idea is, okay, let's install a booster group in order to ensure at least 2.8 bar to the highest floor. Then I might occur in the situation we just saw before. So with the lower stories subjected to too high pressure. So the optimal regulation is, okay, let's keep the booster group, but let's equip every single story or apartment, then it depends on the nature of the building, with pressure controlling device. And this is valid for both hot water and cold water. So this is a cross-section that you are very familiar with. So this is a high-rise building where, of course, the hot water and cold water distribution system are divided by parallel sections. So I think the average is once every 16 floors. So every 16 floors, I have a calorifier, I have a smaller hot and cold water distribution system that I have to manage with pressure reducing valves. So pressure reducing valves can have several features, and we would like to give you some tips about what to look for when we consider them. First of all, they have to be stable and reliable. So Caleffi devices, we would like to show you 5350 pressure reducing valves. They have compensated seat. This will allow the valve to be stable in regulation despite the upstream system pressure fluctuation. It is very important for a correct, stable, and safe regulation. What else? They have to be user-friendly. So the setting of the valve has to be very, very easily reached. So this is why this family of pressure reducing valve can be calibrated without the aim of any tool. It is enough to rotate the upper part of the handle, and there is a special dial to see the presetting. Pressure reducing valves have to be silent, so they have to grant the comfort to the user. If we imagine a hotel and every single washroom is equipped with a pressure reducing device, they don't have to generate vibration or noise. This is very important. And also they have to be user-friendly for the maintenance team. So this family, as actually all the pressure reducing valves by Caleffi, can have a spare part as cartridge in order to be easily replaced without dismantling the valve body from the installation. So it is very quick and user-friendly process. And of course, the pressure reducing valve has to be certified according to the most recognized international standards for potable water application. So this has to be valid for both cold water devices that we identified up to 40 Celsius degrees, but also for hot water devices up to 80 Celsius degrees. The devices are very similar, the shape is similar, the operation is the same, but they are not the same valve. So especially hot water operating conditions are very stressful for the devices. So we had to change some technical details and some materials in order to comply with. So very quickly to the tips. First question. We have to consider the water temperature. Is it higher than 4 Celsius degrees? In case the reply is yes, we have to switch for a hot, we have to choose for a hot water application PRB. In case it was no, we can stay with a cold water application line. Another very important tips, consider the required pressure ratio, so the ratio between inlet pressure and outlet pressure. The limit in order to prevent cavitation issues is 3. So this question is very important. Is the ratio lower than 3? In case the answer is yes, no problem, we can go with a single stage pressure reduction. But in case it was no, so the ratio was higher than 3, we warmly recommend to consider a multi-stage type pressure reduction. So with a first stage PRV and a second stage PRV. Other tip, and we are almost done, consider water velocity. The optimal interval for water velocity in a domestic water system is stated between 1 and 2 meters per second. If the velocity was too low, I would have the risk of stagnation. But if it was higher than 2, I would have serious risk of noise, vibration, and damages to the valve. So if we are between 1 and 2 meters per second, no problem, it is optimum. If we have a different value, we recommend you to review the sizing. Last tip we would like to give you about the pressure reducing valve is consider the PRV position. Is the valve position in a closed loop? If the answer is no, there is no problem. But if the answer is yes, it is a big issue because as per their nature, the pressure reducing valve will close the flow as soon as the set value is reached. So in a closed loop, you can understand the set value is always reached, so the valve will close. So I will have lack of water and my flow rate will not be sufficient to my use and the tendons will comply. So if the PRV is positioned within a closed loop, remove it and reconsider the position outside of it. This is an example of a design with the correct positioning of the PRV. So on the main line, maybe serving the whole floor, I have a big size PRV for cold water, and for hot water, the designer decided to install peripheral units just out of the recirculation room, and it is a good idea. This is a not so good idea we received some time ago, where as you can see, there is a calorifier with the recirculation loop with balancing with a double regulating valve. But as you can see, the PRVs for hot water are within the recirculation loop. So the final consequence of this situation will be lack of recirculating hot water, causing serious issues. So our recommendation to the user, to the designer was, okay, take the PRV just out of the recirculation loop, so solve it like this, and everything was fixed. As we speak about pressure reducing valve, we cannot avoid, and then we are really finished with the presentation, is to equip the system with some devices in order to ensure the PRV is the right protection rate. So, of course, strainers in order to control water quality and avoid impurities to stack, not only on the PRV, but in any other device of the system. Provide the system with shut-off devices in order to be quick and effective in the maintenance. And then consider in medium mix system the installation of water hammer arresters. Water hammer arresters prevent damages, not just to the PRV, but to calorifier, heat exchanger, everything in the system. And this water hammer is caused by the sudden closure of some devices of the system, like lever type taps, solenoid valve. And the quicker is the closing time and the bigger is the system, the higher is the overpressure caused by the water hammer. That's why the water hammer has to, of course, protect the system. It has to be installed in a peripheral position, and also it has to last for several years. That's why Caleffi water hammer arrestor is not like a gas pre-charge type, but we decided to design a stainless steel spring inside of a dry chamber that the water cannot reach in order to ensure the maximum possible efficiency also in the long time period. Also, the performance of these devices is better to be confirmed and certified by a third party, and Caleffi has this complies with QA entity. Consider always the thermal expansion caused by the temperature increase so evaluate the installation throughout the system of expansion tanks, and also consider the expansion of the water in case of multi-staging reduction between primary and secondary device. Now, let's go back to our table of targets, and we see that every one of them has been reached with some care in the technical details of sizing, installation, and positioning of the device. So, just 1 minute to see some good Caleffi references in the GCC area, but in Southeast Asia also. Of course, Caleffi has references worldwide, including the United States, Europe, and South America, and Australia. We focus basically on GCC and the Indian Ocean area. So, for instance, we have the Fairmont Marine in Abu Dhabi for digital mixing valves. We do have the Ritz-Carlton Hotel in Riyadh, KSA. They have units working since 2007. The address downtown restatement is using currently water hammer arresters and the pressure reducing valves by Caleffi. Another reference in Saudi Arabia is the Riyadh Airport Marriott Hotel. Also, so it means that also international hotel groups recognize the skill of Caleffi solutions. If you go back to the UAE, Caleffi supplied thermostatic balancing valve for the address Jumeirah Gate and thermostatic mixing valve for big application in the Mohammed bin Rashid Al Maktoum City in Dubai. Serving each single villa, Caleffi supplied the electronic mixing valve with the BMS integration in Atlantis, the Pole, and also in the Adagio Dubai Deira waterfront. If we speak about healthcare, Caleffi supplied thermostatic balancing valve in Fujairah in the Sheikh Khalifa Central Hospital, where the performance of the system are very important as it is a healthcare buildings. Indigo Hotel Business Bay decided to install also the digital mixing valve for Legionella control, but also some other international hotel chains like the Movenpick Hotel in Cam Ranh City in Vietnam decided to equip the system with electronic mixing valve with Legionella treatment and also pressure reducing valves. The last 3 examples concern the application of a peripheral mixing valve with anti-scald function. One of them is Wanzabil. The Wanzabil designers decided to equip the building with anti-scald feature thermostatic mixing valve with third-party certification in order to ensure the safety to the users. But also in Thailand, they pay attention to this. They installed in the Banyan Tree Bangkok. It is a very, very high star rated hotel. They installed in parallel some pressure reducing valve, but also every single room is equipped with an anti-scald thermostatic mixing valve. Also in Singapore, they decided to regulate with a Caleffi pressure reducing valve for both hot and cold water. This is Swiss Hotel de Stanford. This one were a recent application. So formally my presentation is over. Just I wanted to remind you that Caleffi is present worldwide. The headquarter, production, engineering, and warehouse is located in Italy. And if you need further information, you can refer to the following email addresses. If you want to deepen the topics in the GCC area, you can contact Caleffi team that is based in Sharjah in Saif zone. So Mr. Prabin and Mr. Alan that are also attending the event will be happy to assist you and answer your question. Okay, so thank you for your attention, and I hope I was able to comply with the given time. So thank you again for the attention.
Great, thank you, Alessio. Much appreciated. Fantastic presentation. That was very helpful. So I just want to highlight that we got around 160 people on the call. We've got a few questions to go through. If I may read the question to you, and maybe between yourself and your colleague, we can just chip in and go through those questions. Really.
Okay. With pleasure.
Yeah, the first one that I've got is that what will happen if the TMV fail during the pasteurization cycle? How do we deal with that?
The TMV at the point. Let me just refer. Can I still share my screen, so maybe we can we can use the diagrams. So this is the one, right? So which mixing valve are they referring to? The centralized performing the thermal disinfection, or the secondary one at the point of use?
Yeah, I think it's a secondary one. To be honest, it's to do with the pasteurization loop.
Normally, it is not failing since it can withstand very stressful pressure conditions. So it is engineered to comply with 6:1 pressure ratio. But in case of failure, of course, during the thermal disinfection, there is a potential risk for the user. That's why we recommend a proper water treatment. So if the water is treated properly, the inner materials of these devices are anti-scale. So their performance is very, very good. The resistance to scale and dirt is very, very good. And furthermore, in Caleffi catalog, there is also a further thermostatic anti-scald element in order to give even more protection to the users. In case instead this valve is failing the thermal disinfection, and it might happen, for instance, let's suppose disinfection time has come and we want to have 70 degrees all over the building, but the water in my storage is too cold. The water will not perform it. So this failure will be recorded and it will be brought in case of BMS also. This message will be brought to the responsible person for Legionella treatment, and he will react accordingly, maybe increasing hot water temperature in the storage and performing the disinfection again. Everything will be recorded.
Okay. Do you have a fail-safe on this TMV? If, for example, if the cold water fail, is that going to switch off automatically?
This one?
Yeah.
Yeah, of course. And this performance is certified by a third party. So before we mentioned TMV3 and TMV2 certifications, and these are the third-party certification that state officially that the valve complies with some European norm, in particular from UK, but also from Europe for anti-scald performance. So TMV2, now maybe it is too small to see. TMV2 is anti-scald performance feature referred to the residential type of application like dwelling. TMV3 is even more restricted and it is related to healthcare buildings. So the parameters of the test are very, very, very restricted. So it is very difficult to comply with TMV3 and TMV2, but Caleffi devices comply with.
Okay, the next one that I've got for you, that with the 6000 series TMV, if this is installed at the centralized vessel, how will the TMV be maintained, descale, etc., whilst keeping the building operational?
So the valve is very, very robust, so the maintenance level is minimal. In case of some failure, for instance, to the probes, or maybe for the actuator, everything will be displayed on monitor or BMS reported. In any case, the inner mechanism is equipped and the software is equipped with a function that we call anti-clog function. Anti-clog function will bring the valve to do a complete movement open and close once a day. So with this movement, any formation of scale inside of the regulating element is avoided because the valve completely open and close once a day, even if low season occurs. So this is typical also in Italy at the seaside in winter time when nobody's using the hotel on the coast. These valves keep moving at least once a day in order to remove sediments and scale forming on the inner regulating mechanism.
Okay, that's good. Next one. What is a simultaneous use factor?
Simultaneous use factor roughly is a percentage, is a probability. Okay, so if you think about a hotel with 100 rooms, okay, the sizing of the plumbing system or plumbing devices of the calorifier is not the simple sum of every single user point. This will be very, very, very high value, and the system in the end will be very much oversized, and so therefore the regulation will not be good. So the simultaneous use factor is a percentage of use. I mean, I obtain before the rough sum of my users. So I had a hotel with 150 rooms, so 150 basins, 150 showers, and this was the simple sum of all my elements. Then the next question, what is the probability of all these 300 devices to work together? Is not 100%, is much, much lower. And the higher their number is, the lower the simultaneous use factor is. So this also depends on the type of the building. If you figure out, for instance, an airport, the airport is working 24 hours a day because people is using washroom in the airport 24 hours a day. But if you think at a office block at nighttime, nobody will be there. Or if you think to a hospital, unfortunately, especially in this period, hospitals are full. So the simultaneous use factor of a hospital has to be much higher if compared to the one in the hotel. So it's a probability. There are some norms that like EN 806 for Europe that state these percentages. Anyhow, I forgot to mention before, on Caleffi website, there is a sizer. There is a software able to help to estimate what is the design flow rate, depending on the nature of the building, depending on the number of basins, shower, bath tubes, and so on. So it's very useful. We often use it when we face some project to support.
Okay, great. Next one. What is the price difference between the thermostatic and the digital versions?
Okay, basically it is the regulating element. The thermostatic devices, I don't have any cross-section in my presentation, but inside of them, the thermostatic mixing valve have a wax sensor and an obturator that expands or gets smaller according to the temperature variation. This change in volume will determine the bigger opening or closing of hot water and cold water inlet. On the other hand, the digital mixing valve inside has no wax sensor, but it has two PT probes. So the metering of temperature is made a completely different way. One is electronic, digital, and the other one is purely mechanical. So in this type of valves, there is no electronical, there is no sensor. The sensor is inside.
Mm-hmm. Okay. Next one. In hot countries, would the emphasis be reducing the heat gain in the cold water supply in the domestic water system? I don't really understand this question actually.
Me neither, but probably they want to mention that you might have Legionella problems even in cold water line. It might happen in your country where cold water actually in summer is not cold, so it is warm. So reaching these values more than 25 can be easy. So our suggestion is to forecast a system to cool also cold water in summer season. Maybe a heat exchanger or some very, very prestigious installation. They have chilled domestic water distribution line, then it depends on also on the budget of the system. But take into account Legionella outbreak not just in the hot water system, but also in the cold water system in some countries, because in that countries, cold water in summertime gets to warm water with the probable Legionella outbreak.
Okay, next one. Can you put PRV in the hot water return? I think the short answer is no.
The short answer is no. For what maybe I too briefly explained before. So the problem, okay, this diagram can be good. So the PRV is a mechanical device. So how does it work? As soon as you get downstream the pressure value that you preset, the valve will close the flow rate. So if you install it in a closed loop, and the closed loop is pressurized, is a closed pressurized system. So the pressure set value is always reached. It means that the tendency of the PRV in the closed loop will be to stay closed, so to obstacle the normal water flow. That's why this position is absolutely not good. But also if you put it here, it will not be good. It has to stay out of the recirculation loop.
Okay, I think next one, which is a bit similar, is a double regulating valve the same as thermostatic balancing valve?
Absolutely not.
Short answer is no.
I also put absolutely before in order to give emphasis to the reply. DRVs are a good way of balancing, and for years and years, the balancing of domestic hot water recirculation system was done with the double regulating valves, because in the end, they allow the system to have the correct flow, and they are compatible with thermal disinfection, but installation and especially commissioning take a lot of time, and they are not easy. And also, in the last years, people is paying a lot of attention to energy waste, and this is our case also in Europe, but also in the GCC, especially in Dubai. So green buildings and low consumption buildings are more and more appreciated. So when you install and calibrate the DRV, they work, but they are not able to modulate, so to throttle, to reduce the hot water consumption when it is not needed. And it is something that the thermostatic balancing valve can do. So this is the hydraulic characteristic chart of Caleffi thermostatic balancing valve. You see that every single line is a presetting value that you can decide on the knob. When we are very far from the set temperature, the KV of the valve is the maximum possible, so the valve is completely open. But the more we get close to the set point, the KV is reduced up to a minimum value, and this minimum value is the minimum recirculating value. DRVs are always here, so they always supply the system the maximum possible flow rate, and this is an energy waste.
Okay, I think last one, or maybe last. Check which one I did not capture. Why not circulate the water at the stored temperature instead of mixing it? I think they're talking about the centralized mixing valve.
Yeah, okay.
From your tank.
Let's go to one of the first. Okay, for a matter of safety and for a matter of energy saving, basically. So let's suppose I have 6 degrees, but probably also 65 or 70, depending on the building. The heat loss of the system depends also on the temperature of to which I distribute the water, and also the safety of the users that can be also quite delicate. Has to be always ensured. That's why this first temperature reduction. So if I distributed the water at 60, 70 Celsius, I might occur in some issues throughout the season. Think about a leakage of a gate valve or a ball valve in the false ceiling dripping at 65 degrees. It can be a very great issue, especially in a hospital where maybe you can have children or weak people or elder people, and think about also the maintenance of some components that are managing water at 60, at 65, and also to take into account the thermal losses, so the energy bills at the end of the month.
Okay, but in terms of code, really, you distribute at 60 degrees, and then you return back from the furthest point at 55 and back to the main storage tank at, let's say, 50 degrees.
Technical-wise, it is feasible, but for a matter of safety, it is not recommended, and some European standards also don't recommend it. So the achievement of a certain temperature value in the distribution system shall be reached just for some minutes during the thermal disinfection. Just to give you an example, Dubai municipality guidelines wants 70 degrees, if I remember well, for 5 minutes. What Caleffi is recommending, its literature, is something like 70 Celsius degrees for 10 minutes, or 65 degrees for 15 minutes, or 60 Celsius degrees for 30 minutes, not more. It is also quite expensive to keep kilometers of recirculating pipe at 70 degrees, and also dangerous.
Yeah, I mean, 70 degrees is mainly for pasteurization mode. Yeah, the main distribution for domestic side is still correct. 60 degrees. If you go with DM, you need to pasteurize, I think, every 6 months for 5 minutes at 70 degrees.
Yeah, but if you have a hospital, the recommendation is to do it more frequently, of course.
Of course, yeah. All right, I think last one, is PICV the same as PRV? Again, I think short answer is no.
Once again, the answer is no, because the PICV is a flow rate regulator that will keep the downstream flow rate constant regardless the pressure fluctuation. Instead, the pressure reducing valve is a safety device reducing the pressure from upstream to downstream in order to regulate the flow rate to the final user. Okay, the final result is a regulation of the flow, but the operating principle is completely different. PICV are using closed loops, PRVs are using open loops.
All right, okay, we've got a few more actually, if you can run through that quickly.
Yeah.
What could cause the anti-scale to fail? I have commissioned system and often the anti-scale failed. So what is the cause of anti-scaling failing?
Honestly speaking, we never face anti-scale failing because the valves are tested one by one, and the anti-scale, sorry.
Anti-scaled.
Okay, so the prevention from scaling, from debris.
I guess so, yeah.
Okay, so the materials are engineered and tested in order to be resilient to scale formation. So they are tested in Caleffi labs for months in order to be smooth and always in good condition. Moreover, if you remind, we mentioned that these kind of devices have strainers and check valves and the inlet in order to protect the internal elements. So the valve can really face very serious and hectic condition without any particular problem.
Okay, what is the temperature difference required for the valves to work efficiently?
It depends on the family. It depends on the family of valve. This is reported in the technical documentation. So if we have time, we can see one together. For instance, let's look for 5 to 5. Okay, so let's look at the big sizes, but thermostatic type. Can you see the technical data sheet in front of you?
I can, yeah.
Okay, for this family, for instance, the minimum temperature between inlet of hot water and outlet mixed water to ensure the performances stated in the data sheet, so accuracy ±2, is 15 Celsius. Other families have a different type of sensor inside, and they have slightly different values. So every technical data sheet is reported on Caleffi website that you can download for free, or you can revert to the email addresses we indicated you, and maybe I can indicate once more. Okay, it will take a moment. Okay. So once again, if you have questions from the GCC area, please revert to Mr. Pravin and or Mr. Alan. And in general, you can refer to info@caleffi.com or directly to my email address. By the way, the whole Caleffi technical documentation is available for free on the website without any registration, so you can jump in and browse and download whatever you need.
Okay, one more question. Relating to the question with regards to maintenance from the central TMV, you said that cleaning and disinfections are not required. Sorry,
can you repeat the question?
So let me read that again. Relating to the question about maintenance of the central TMV, are you saying they don't need cleaning and disinfection? Are the correct HSE guidance advisors?
So we can say that this kind of digital electronic mixing valve cleans itself by itself because of the anti-clog system. Of course, in case of any failure in the probes, if the probes are giving a bad signal, or if the actuator has some issues, you will have some alarms blinking on the display and reported to the BMS system. But consider that these kind of units are very robust. So they are built and engineered to last several years. If you remind when we faced the Ritz-Carlton Hotel in Riyadh, I told you that the units are running since 2007, and they are for real. We have been contacted a couple of years ago just for a spare probe and a spare gauge, but the units were running very, very fine, even if they were quite old. So the valves are very, very, very resistant and robust.
Okay, I think a very last one actually. I've got a question.
Yeah, no problem, no problem.
Yeah, he's saying that he don't have confidence with regards to the thermostatic disinfection, and based on his experience, it seems that the bacteria kind of grow back very rapidly. So disinfection is short term, but again, recolonization might happen very quickly if the system again is wrongly designed, I guess.
So in that case, of course, if the system is wrongly designed, or if it is not correctly balanced. So previously, we mentioned that even if everything is sized correctly, the mixing valve is operating correctly, and the water has the right temperature, but it is distributed in a non-correct way, all my efforts will not be successful. So also a system balancing correct has to be verified. So that's why our recommendation is looking at for the right one, to equip the thermostatic balancing valve with a temperature sensor. This is the very most complete configuration in order to ensure that all the branches have the right temperature. So think about the hotel we discussed before. Okay, the mixing valve is operating the disinfection, okay, but the last floor on the top is not correctly balanced, and in that floor, temperature is not reaching the correct set value. The Legionella at 10 number floor at the last floor will be still alive even after the disinfection. So it will start again infecting the rest of the system. That's why it is so important, the monitoring of the temperatures throughout the building. It can be digitally, or we can use the dial on Caleffi thermal balancing valve. But the thermal disinfection, if carried the right way, is effective as the chemical one. And also, moreover, it doesn't have the same undesired effect that sometimes occur when we do the chemical one. I mean, the affection of the water quality, for instance. So the chlorine that might affect the water smell or the water taste, and also the expense caused by the chemicals that have to be stocked, but not for such a long time because they expire. So the managing of chemicals sometimes can be an issue. Since we are already equipping the system with a centralized installed mixing valve, why don't we consider the selection of a valve with the thermal disinfection feature? I hope I replied also this one.
Yeah, sorry, I'm just have another question coming through actually.
No problem.
CIBSE Guide G has a procedure explaining how the sizing of hot water secondary circulation system using thermal balancing valves differs from sizing without this type of valve. Do Caleffi provide the necessary data for this sizing procedure?
Of course, I think it is enough to take a look to the hydraulic characteristic chart. I just reported it for your information, so it's quite small, but it is enough to understand. So, of course, once we size the recirculation loop for the disinfection, we have to take into account that we have to keep for a certain period of time to a certain temperature a branch. Okay, so we have to take into account the hydraulic characteristic of the valve. You will see in the technical data sheet that there are different kV values of the valve. There is kV max, there is kV min, that is the modulating one, the throttling when the valve is starting, reducing the flow to the minimum, and there is kV disinfection. There is kV disinfection, that is the hydraulic characteristic when the valve is in disinfection phase, and that is the value that you have to take into account when evaluating the thermal disinfection flow rate. It's not the maximum, it's not the minimum, there is a specific one that is reported in the technical documentation and differs from the kV value in normal operations. So when sizing, we take into account both of the values.
All right, great. Just conscious about time, actually. I think if there's any further question, I will suggest maybe just get in contact with Caleffi directly, either Probin or yourself. I think I'll just take the screen back. Thank you very much, Alicia, for this.
Thank you for your attention. Thank you.
That was really good. Yeah, sorry. So next event, actually, so next year event will be on thermodynamic solar energy system by Energy. I went through the presentation, so it's a very good one. So I will suggest the audience to tune in for this one as well. The speaker will be Mr. Hugo Dominguez, and date to be confirmed, but it's going to be in June. So that's it. Thank you very much, everyone on the call. We have a very big audience today, and I will take the opportunity to thank everyone for joining the call, and also a special thank to Caleffi and Alicia for this fantastic presentation that was very educative, I hope. So on this note, I will wish everyone a Merry Christmas and Happy New Year. And this is basically the last event for SoPHE this year, and we will reconvene next year already. So that's it for me. And on that note, take care, and thank you very much for attending the call. Thank you, everyone.